GPS and time dilation. Time dilation is written in stone now. Nowadays everybody knows what GPS is, but several decades ago it was for militaries and airlines only. Quick introduction into the subject from FAA. FAA. Airplanes, advanced military shells, and our smartphones take signals from 4 nearest satellites, of the 24 satellites on the orbit, and triangulate the position by deriving distance from each satellite using time delay of the received signal. Clocks on the GPS satellites should be extremely precise, because to get the distance from a satellite, time delay is multiplied by the speed of a signal, which is 300 million meters per second. Thus, even 1 millionth mistake in time leads to 300-meter error in position. In the early 1980s, despite clocks being very accurate, within the first 24 hours clocks were so off that error in the positioning was hundreds of meters, even miles. Turns out it is because time on the orbit runs faster than on the Earth, the phenomenon known as Einstein's time dilation. And although time offset was minuscule, the order of its magnitude was about billionth of a second per second, it was accumulated fast, and led to incorrect distance measurements even within the first 24 hours. 24 hours times 3,600 seconds times 1 billionth time dilation times 300,000 kilometers per second equals 26 kilometers/day equals 16 miles/day error. Actually, because GPS satellites are not too far from the Earth, time dilation rate is lower than 1 billionth, but even with 1/10 of 1 billionth, error is accumulated by 1.6 miles per day. In a month it will be about 50 miles. That problem was fixed by making clocks for GPS satellites run a bit slower, so that when they are on the orbit, where time runs a bit faster, they still stay in sync with the clocks on the Earth. Here is a good explanation on how time delay is used in distance calculation and the need for a fourth satellite signal, due to the error of cheap clocks and receivers. Long time ago, even great Newton believed in absolute time. That time pace is everywhere and always the same. Not anymore. Time dilation is taken into account in modern hardware and software. Now we see how a tiny time dilation distorts our impression of a signal origin, despite it reaching us in a fraction of a second. It becomes clear how off astronomers could be about our universe origin based on light signals traveling to us billions of years from the time that was many times dilated compared to the current time. But even Planaria can change its mind radically in just 2 weeks. Read Free Time Matters ebook, also available on Amazon and Google, on how time dilation solves major mysteries of the universe and explains UFO observations. The most interesting part, the propulsion system of our Milky Way is the same as propulsion of the anti-gravity craft described by Bob Lazar. Atomic clock in your pocket. In GPS and time dilation we discussed how your smartphone uses GPS to identify your location, and we saw that an error in time measurement, even as small as a billionth of a second, is intolerable. GPS and time dilation. Time dilation is written in stone now, medium.com. But if on GPS satellites clocks are atomic, and they are as big as in the image above, your smartphone clock is cheap and small, then how can signal delay time be used at all, if your time cannot be measured so precisely? It turns out, clock of the receiver is not used for triangulation, but your smartphone can still get local time as precisely as GPS satellites get their time from their atomic clocks. For this, extra 1 or 2 satellites are used in addition to the 3 satellites required for the triangulation of the 24 GPS satellites on the orbit. Let's consider 2 satellites S1 and S2, which broadcast their known coordinates, x1, y1, z1, and x2, y2, z2, and their known time t1 and t2. And your receiver/smartphone are as ignorant about its own position, x, y, z, and its local time t distances r1 and r2 from the receiver to the satellites are unknown as well, but there are 2 known formulas for the distance. One is by time taken for the signal to reach the receiver multiplied by c, the speed of light. Another is by Pythagorean formula, which uses coordinates. Thus, we have following equations. equations. To get rid of T2, x2, let's subtract last two formulas from each other. R12's R22 equals C2 times 2T1 plus 2T2 times, thus, C2 times 2T1. Since only T, X, Y, Z are unknown, let's rewrite the above equation simpler, using known instead of real numbers. Known 1 times T plus known 2 times X plus known. We got a linear equation with 4 unknowns, using data broadcasted by satellites S1 and S2. Absolutely the same way we can get another linear equation from satellites S1 and S3 data, and another from S1 and S4 data. Let's for a moment use fifth satellite data as well, thus we will have 4 linear equations with 4 variables. That is enough for the receiver's computer to solve 4 linear equations and find T, X, Y, Z. We used extra fifth satellite data / equation for simplicity, to stay with linear equations only. Actually, 3 linear equations will do, not yet to solve, but to resolve unknown X, Y, Z via T. Then the computer can substitute X, Y, Z as T expressions in the equation for R12. R12, in the image above, and find T from that equation. Thus, your smartphone knows / calculates local time T as precisely as the GPS satellites know their local time via their atomic clocks. Read more in Free Time Matters ebook, also available on Amazon and Google.